1. If you have 2 points, you can draw a straight line between them. 2. If you have a straight line, you can extend it indefinitely. 3. Given a center and a radius, you can draw a circle. And the fourth is that all right angles are equal to each other.
But postulate 5 gets the big guns.
Which is that if a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side on which are the angles less than the 2 right angles. Here's one formulation. If you have a line and a point that is not on that line, then there is a single, unique line which will be parallel to the first line. For this reason, the fifth postulate is often called the parallel postulate. In total, mathematicians spent more than 2,000 years trying to prove the fifth postulate, but everyone who tried failed. Then, around 1820, János Bolyai, a 17-year-old student, started spending his days and nights working on the mystery. His father became worried, and he wrote to his son, "You must not attempt this approach to parallels. I know this way to the very end. I have traversed this bottomless night, which extinguished all light and joy in my life. I entreat you, leave the science of parallels alone. Learn from my example." But the young Bolyai didn't listen to his father. He could not leave the science of parallels alone. After years of work, he realized that maybe the fifth postulate can't be proven from the other four. It could be completely independent. See, according to Euclid, you could have only one parallel line through a point, but Bolyai imagined a world where there could be more than one parallel line through that point. But how? Well, who said you needed to have a flat surface? On a surface that is curved like this, you can draw more than one line that is parallel to the original line. But wait a second, those lines don't look straight. Well, what makes straight lines special is that they're the shortest paths between 2 points. On this surface, those shortest paths just look bent because the surface is curved. Here's a more familiar example. Airplanes always try to fly the shortest path between 2 cities. They're basically flying in a straight line, but that line doesn't look straight on a map because the surface is curved. These shortest paths on curved surfaces are called geodesics. So, all these lines are straight, they just don't look it because the world Bolyai had imagined turned out to be curved. We now know this as hyperbolic geometry. In 1823, the 20-year-old János wrote to his dad, "I have discovered such wonderful things that I was amazed. Out of nothing, I have created a strange new universe." But Bolyai had been doing more than just tackling ancient math mysteries. In his 20s, he joined the army, where he continued developing 2 of his other passions, playing the violin and dueling. He had mastered both, but with a sword in particular, he was unmatched. Perhaps because of his many talents, Bolyai grew arrogant and found it difficult to accept authority from his superiors. That made him hard to get along with. This reached a peak when, during one of his deployments, 13 cavalry officers from his garrison challenged him to a duel. Bolyai accepted their challenge on the condition that after every 2 duels, he could play for a little while on his violin. Bolyai fought each of them in succession, winning all 13 duels and leaving behind all his adversaries on the square. While Bolyai loved dueling, his first love was still mathematics. In 1832, 9 years after he discovered his strange new universe, he published his findings as a 24-page appendix to his father's textbook. Extremely proud and excited about his son's work, Farkas Bolyai sent it to perhaps the greatest mathematician of all time, Carl Friedrich Gauss. After careful examination, Gauss replied a few months later, "To praise it would amount to praising myself, for the entire content of the work coincides almost exactly with my own meditations, which have occupied my mind for the past 30 or 35 years."